All right, recording is rolling. It is Monday, March 18. So you guys remember last week we were doing relativity. Uh, a few days we are looking at this page. I think it was Wednesday, Thursday. We were solving these algebra-based questions for relativity. You guys remember twin paradox, all the mass energy equivalence. And then on Friday, I think it was we were doing the speed of light puzzle. You guys remember Fizeau's cogwheel? Now, some of you guys already turned this page in. If you hadn't yet, then turn it in today or tomorrow, and I'm getting those graded here pretty soon. All right, so I do have like about a day and a half left of relativity stuff, a little bit of stuff. It's like mostly video based. Today doesn't feel like a video day. It feels like we got to do something a little bit more active day. So let's build toothpick bridges. That's what we're gonna do. Toothpick bridges. Show you guys a model from sometime in the past, right? Ooh, what we're gonna do is open up a space between the desks. I'll give you guys a 12 centimeter gap this year, and say set a toothpick bridge. Then on top of that, I'm gonna set this roll of tape, masking tape. It has a diameter of 10 centimeters itself, and then put on the grade tray, and then start stacking some weights. We're going to do that until this bridge breaks. See how much weight your bridge can hold. So give you guys some pointers though. Your budget's going to be 100 toothpicks, which is what's in this pack is 100 toothpicks. So I'll give you guys, each team is going to get a pack. And let's just say it's school glue, right? So you guys get this and this is your budget. And your goal is to span a 12 centimeter gap. Now, guys, if there's a 12 centimeter gap, do you want your bridge to be exactly 12 centimeters long? Ooh, no was the correct answer, and you guys got that right. Bing. You want it to be more than 12 centimeters. Maybe like 15 or 20 centimeters, probably pretty good. I'm gonna recommend too that you guys take. We're doing this today and tomorrow. Put it together, and then we'll test these on Wednesday. That's the plan. So my recommendation is to glue together the panels or make individual panels today. Come with a design and start the gluing process. And then tomorrow, glue all the panels together, and then that can dry overnight, and then it'll be ready to go on Wednesday. We'll see whose bridge can hold the most weight. Right? That'll be the test. Also, give you guys a hint. Like, how could you hold the most weight? Like, what's like a really good tip to hold the most weight? So let me go all the way back to last semester. If you guys remember last semester, I had you guys take some spring scales and do a bunch of different lab activities. It was like 10 different mini labs. You guys started doing 10 different mini labs with the spring scales. And one of the setups involved you guys took took 3 spring scales, okay, and started holding a couple pretty close to vertical, and there was a third one here, and then hook on a lab weight here, right? Let's say, for example, if this was like a 10 Newton lab weight, like this guy right here, right? You hook on there, right? And they said, hey, what was the, guys, if this is 10 Newtons here, call us 10 Newtons. What was the force rating in this middle spring scale? 10 Newtons, right? And what was the force rating in each one of these? Pretty close to. Yeah, so they add up to 10. Yeah, probably about 5 and 5. 5 Newtons, right? Now, if you start to spread them out more and more, maybe it's like 5.5 and 5.5, some point 6 and 6, right? What if you did this though? You guys remember, I had you guys change the angle until it was like more and more and more of a T shape. Okay, so let's say same scenario, got these all hooked together here, got the same 10 Newton weight here, 10 Newtons. Okay, what was the middle spring scale rating again? Yeah, still 10 Newtons, right? But what about each of these guys? What's each of these guys now? It was huge. I'm just going to make up a number. It was like 30 Newtons and 30 Newtons. It depends on the angle, right? If it was like perfect equilateral, like between these two, maybe halfway between these two, maybe it could have been like 10, 10, and 10 at some point. But yeah, the closer you make it to a T, these forces just keep getting bigger and bigger and bigger. Could you ever make a perfect T? No, you can never pull those out to a perfect T. You do that. Okay, now that's a tension example. This bridge is definitely going to be compression, right? We're like pushing. Well, I guess a lot of parts will be compression. Maybe if it starts to bend, or maybe the bottom part could possibly go into tension a little bit, right? Maybe that can happen too, right? So what's the optimal way to build your bridge? Now think about this example I was just telling you with the spring scales and tension, because you can apply that to this, right? Suppose you're looking at a cross section, and one way you can build a cross section. Now you guys come up with whatever design you want, but Triangular cross sections are popular, right? Maybe they're kind of easier to build, right? And what if you have a flat cross section versus a tall cross section? And here, if I draw like the rest of the bridge, maybe there's like something like this going on. There's like a road for a car to go through, and it's going through there. Right? Versus, ooh, what if you have like a tall bridge, right? And then here, have like a road going through, right? A little car. I guess you've been through that one too. Right, so you guys know I'm putting weight on from the top. Right, so I've got a weight here. I've got a weight here. Right. Now, one of those is a lot stronger than the other. Right. Which one's stronger, the one on the left or the one on the right? Let me see, show hands, show hands. Who thinks the one on the left is a stronger design, hold more weight? Who says the one on the right is a stronger design, hold more weight? Yeah, okay, most of you guys got that. Most of you guys think this one right here. Because it's the same idea as, maybe we got this mixed up, right? Maybe this picture should match this, and this picture should match this. Oops, I mixed up my left and my right, right? You guys get the idea, right? This is kind of like this, and this one's kind of like this, right? So if they had equal forces on them, then let's say it's like 10 Newton weight. So I'm going to take this 10 Newton weight, stack that around top there, right? This one's going to split pretty close to 5 Newtons and 5 Newtons in each of these toothpick legs, right? But this one's going to be a lot more than that, right? Maybe it's like 12 Newtons and 12 Newtons. Right? And the flatter it is, the more force routes into horizontal, and their overall has a greater force. Yeah. So the taller you make it, it's a stronger design. That's probably one of the biggest tips I can give you. Right? You know what that's kind of like is you guys know like a 2x4 piece of wood, right? What if you have like a 2x4 and you lay it flat like this, versus what if you turn the 2x4 up like this, right? And again, each of these is going to have like a vertical weight. So I'm going to put a vertical weight right down top of these. Okay? Which one's going to break first, and which one's going to be stronger, and it's going to break last? Do you guys think the one on the right is going to be stronger? It's going to hold a lot more weight? Yeah, right, because that's kind of like this too, right? Right, so you guys good with tips? Right, so I'll leave this up here. Remember, again, your goal is to span a 12-centimeter gap. Put this roll of tape on the top, and then start stacking on weights. Whose bridge can hold the most weight? I will walk around, give each of you guys a pack of toothpicks. If you do all your work on a paper, make sure you write your name on your paper. That's probably a good idea, actually. You can hold all the toothpicks and glue. You guys can put it on the lab table overnight and pick it up tomorrow and continue working then.